Hi everyone, and welcome to the third series, the third video in the series of Risa tutorials. Today I'm going to talk about Risa3D and the differences between the 2D education version and the 3D version. So if you have gone through the first two tutorials, here's a look at the different things that we covered in the first two. Basically creating and solving a model, and then some more advanced topics in 2D modeling. And so here we are in video 3, where I'm going to talk about the things that separate Risa3D professional version from the 2D education version. Alright, so if we skip ahead a few slides here to the 3D, so this is what I'm going to cover, and then the problem, the example problem here is what I'm going to do as my example. So when you start up, so you recall that in Risa2D, which I thought I had open here, but maybe not. So as I, it says it's already running on the system. Well, that's odd. It's possible that you cannot run Risa3D and Risa2D education at the same time. You used to be able to, but so let me close out of that. Okay, so this is what you'll recall. This is what Risa2D education looks like, and as I mentioned in class, likely the interface used to look the same, but it no longer does. Right now it has a bunch of icons up here that you probably will not remember or translate directly to the new version, but a lot of these are the same and they translate over. But the thing that I want to point out here while I have this open is that, you know, when you go to draw a member, it asks you directly for the area, the moment of inertia, and the Young's modulus, and then whether or not the I end and J end are fixed and pinned. So that's going to be a little bit different in Risa3D. Alright, so if I click on Risa3D, you can't see it because it's actually on the other screen here, but it takes a second to load, and then it brings up, brings up this little dialog box thing, intro thing, which is kind of neat because it has recent projects, so you can open recent projects, or you can just close this, and then, excuse me, it will bring up this little guy, which talks about the project, and this sticks with your file, right? So this is kind of nice because then you can put in stuff like this, and you can say, oh, this is my example model, and, you know, maybe project number. So, and you can put in some notes and stuff like this. So professional companies use this to kind of keep track of, you know, what version of the model is this, and did you remove some components, or, you know, if there's anything special to know about the model, you can put that in here. You can also say, don't show me this ever again. And then you say, okay, and you are left with the screen that looks like this, very purple compared to the previous versions. And so a quick tour of this. So the biggest change here is that we've gone to a ribbon system. And the big change here, I can't even remember at this point what year or what version it was. I think it was the difference between 17 and 18 or 18 and 19. Now this is what you're looking at here is version 22. When you're watching this, you might be on version 23 or 24. But in any case, the big shift, we went from essentially a menu-based system to a ribbon-based system. Word and Excel went through the same thing. Many of you probably don't remember that. It was a long time ago. But the idea is that, you know, you click on these headings up here and you get different ribbons at the top that give you lots of different things. And so you have to, if none of you are translating from the old version of Risa to the new version, and so you won't have as much trouble as I did trying to figure out where they moved everything, right? So the new version I kind of like now that I've gotten used to it. It's got all these different The ribbons will quantify and group, if you will, the different things that you might need. And so there's all these, so there's, the 5 or 6 things at the top: home, modify, view, drawing tools, spreadsheets, and advanced. And then once you've solved something, there's a results one. Most of the time, they're pretty easy to remember where stuff is. Home is a little quirky. It's got drawing, a lot of drawing things, and the solve button here. And then this guy up here where it says quick view. And if you have better resolution, or I guess, better resolution in your screen, let's see if I can fix that actually. Then you can see this whole thing all at once, and you can see more. Let's see, that is helpful. Yeah, okay. So you kind of want to look at it like this, right? You want to be able to see the entire ribbon, if you will, up here, including all this quick view stuff. And then around this, there's this block in the middle. That's the 3D view. There's a bunch of stuff, both the top of the block and the left of the block. The top of the block is mostly view stuff, so you can rotate and view around. You can also, hold down Shift and press if you're using a mouse, you can press your scroll wheel down and you can rotate. Or if you just don't hold down Shift and you press your scroll wheel around, then you can pan. Or you can, I believe you can, I feel like there's a way. And then there's these up here, XY will get you back into the front. You can hit ISO. So these are super useful if you're trying to move around your model. Then there's a couple of views up here. There's a deflected shape view. There's a apply your loads view. We'll get to that later. And then 2 new things. On the right is this thing called the Explorer. These are all your spreadsheets, which we'll get to, but this is sort of the new version of the floating spreadsheet holder that was before. And then this guy on the left, the properties one, this is totally new, and this is really nice. It's a lot like AutoCAD. If you click on a member, it'll tell you a bunch of stuff about the member, but in here, and you can change it, right? And so it's the same. AutoCAD has a similar thing. It'll tell you if it's a line or a spline or whatever it is, and then you can move stuff around and change it. So, okay, so that's kind of the outline of the space here. You see there's a grid. So the next thing I want to talk about is the units and the global model settings. Those are both up here in the top left. And so if I click on units, you'll see that here I have it's in feet and dimensions are in inches, forces in kips. Linear forces are in kips per foot. And so if I want to change any of that, particularly for your projects, you probably want to change lengths to feet and maybe forces to pounds. So this is where you would do that. You can also switch to metric units. And then secondly, here you have a thing called settings. So if you click on that, it gives you a bunch of different settings, such as how many internal sections it's going to solve. A lot of these are more advanced, and we'll get to them in a second structures course. You can sort of switch which way is up if you prefer Z to be up instead of Y. I like Y. And then there's some stuff in here about codes, and so you won't really understand most of this, but this has to do with, which year essentially of steel, concrete, cold form steel, wood, which codes you're using. Because as I mentioned in class, probably, Risa is a 2-step process, and the full version is a 2-step process. First, it does the structural analysis, and then it applies a bunch of design codes. And so here's where you tell it which design codes to apply. Okay, and so then, so the first main difference here between Risa 2D education and Risa 3D education is this third one down over here on the Explorer on the right-hand side is this thing called section sets. And so if you click on that, and then it's got a bunch of things across the top, a bunch of different tabs here. and it's basically a bunch of different types of materials. And so if I click on general, and so the idea here is that, and one of the things you'll notice about the shape here is it has a material, an area, an I in both the Y and Z directions. That's I, moment of inertia. And then it also has a J, which is sort of similar to polar moment of inertia. So the idea here is that you, instead of applying the I, the moment of inertia, and the area, and the material every time you draw a member, you just create these general section sets, or generalized pieces or labels, or categories, if you will, and then you assign those directly to members, right? And so the advantage, there's three advantages to that. One, you only have to define it once, right? So if you have a whole bunch of pieces that are all the same, you don't have to define it every time. You just define it once, and then you assign it to all those members. Number two, you can change it. So if all those pieces are defined as general section 1, then you can change them all, right? If you want to make it the piece bigger or the pieces smaller, then you can just change it, and they all change. You don't have to reassign each one. And then third, the way it's set up, you can actually access a huge library of predefined shapes. So here, if I go over here to hot rolled steel, and I click here under shape, it says, oh, you have these W sections, which W stands for Y flange, which is basically a standardized steel I-beam. And if I scroll up and down, you can see that there's a huge number of all the different predefined sections. And if I click on some of them, you can kind of see their dimensions over here on the right. And you can do steel tubes and steel pipes and steel channels and all these different things, right? And so you don't have to type all that in or figure it out. You just grab the one you want and you're done, right? So that's super useful. In this class, we'll focus mostly on either steel, which is generally hot rolled, or just use the general tab. There is a wood tab, and you can use that. And if I click on those shapes, you'll see that there's different standardized bits of wood right here: 2x6, 2x4, 2x12. But you have to be, wood's a little quirky, and so you have to be a little careful with using wood. So in this class, a lot of times what I'll do is I'll use the general material, and then I'll just create a wood material. And so one of the advantages of that is that the wood ends up being isotropic, which is not real, because wood's not isotropic, it's orthotropic. But it makes your analysis a little bit simpler, and you don't have to deal with some of the quirky code things of wood, because really all you're after is what is the stress in my wood, right? Okay, so that general description being done, and I should probably have a page on this PowerPoint about general section sets. So for my example problem here, I have 3 section sets, right? And I have wood. I've given you the general modulus for the wood, which is 1500 psi. And then I have a 6x6, a 6x12, and a 4x4. And so what I'm going to do is I'm going to go in here under section sets, and I'm gonna call them 6x6, and then I'm going to go in here in the shape. And of course, we all know that a 6x6 is actually 5.5 by 5.5. And so I'm going to say OK. And then for the material, well, I could pick a wood material here, but I don't want to do that. And so what I'm going to do is I'm going to go under materials. And materials operates the same way as sections. You can create, it has with all the same advantages, right? You create materials, and then you can apply them to all or some of the members, and et cetera, et cetera. You can change them all at once by changing the properties of the material. And when I open the material thing, you'll notice that these are a bunch of steel grades that we use a lot in structural engineering, and they're all predefined. A992 is a steel grade that most W sections are. And so, and if I go to wood, you'll see that there's like, this is Douglas fir, solid sawn, and it's grade number 1. So these are all predefined, but I'm going to go over here to general, and you can delete some of these. So here's concrete, this is going to be 3 KSI concrete, 4 KSI, normal weight, lightweight. There's a generalized steel. If I don't want to use any of these, I can hit F4, and it will delete some of them. just because you know, you might be annoyed that there's all this stuff in your model. And so I'm going to create a material which I'm going to call General Doug Fir. And remember that that was 1500. And then the shear modulus of that is probably about 600. There's a relationship between shear. It gives me this warning because it doesn't match. If it's an isotropic material, you'll recall hopefully from mechanics that there's a relationship between Poisson's ratio, shear modulus, and Young's modulus. And I'm not matching that, and so it's annoyed. But that's okay because I don't really care. You do, however, want to try to keep it somewhere in their neighborhood of what a realistic value, which is roughly half of the shear modulus is generally roughly half or a third of the Young's modulus. The thermal coefficient of expansion of wood, I don't know what that is. I don't really care. I'm not doing a thermal problem. My density is going to be about 35 pounds per cubic foot, which this is in kips per cubic foot, so it's going to look like that. And then this is kind of new. It lets you actually pick if you want it to be orthotropic. So that's kind of nice, although I don't know why. It's kind of funny that the modulus gets grayed out. Also, you need to be careful about my units, right? E here is 1500 psi. And so that actually, I'm going to go back to, oh, interesting. Okay. It lets you, yeah, that's pretty advanced. So you're defining all of the different characteristics of your orthotropic material. So let's go back to an isotropic material. And of course it made it steel again. And we'll go back to, we're going to stick with 1500 KSI. That's actually a mistake. This should be KSI. Okay, so that's that. We'll make this 600 again. And thank you. And then we'll be good. Okay, so now I'm going to go back to my section set. I'm going to change this to my general wood. Now there's a rigid general section set. We'll talk about that later. That's basically what it sounds like, a rigid member. What else did I need? I need a 6x12 and a 4x4. So we'll do the 4x4, which is going to be a square. That's 3.5 by 3.5. And if you and then the 6, oh, I need to fix my material here, right? I don't want it to be rigid. And then my last one is a 6x12. And I'm going to make that 5.5. So now one thing that's quirky, a little bit quirky here, is that if I want to make this 5.5 by, what did I say, it was 11.5. Oh, it will do that. Okay, it used to be that you had to have the depth. Let's see if it does that. Yep, it does. Okay. It used to be that you had to have it vertically. The depth had to be greater than the width. So that's no longer the case. Apparently, they fixed that. So now I'm gonna, but I actually want it vertically, and so I'm gonna rotate it. Right, I'm gonna switch my depth and width, and that rotates. Okay, so there we are. It's calculated my IYY, moment of inertia in the Y direction, moment of the Z direction, and I'm good. So now, if I take a look at my problem again, it's going to be, I'm actually going to move it. You guys can already see it, so I'm going to move it over here. And so it's 10 feet tall, and 12 feet wide. And so the first thing I want to know is what are these grids? And I always have a hard time in the new version finding where the grid gets defined. I'm pretty sure it's under drawing tools. And so right up here it says you can display the grid or not, right? So that's how you hide it. You can make it radial if you want. That's pretty wild. I don't want to do that. And you can change which plane it's in, and then you can change how many increments it is, right? And so if I want this to be in 2-foot increments, for example, I could say 10 at 2, and then I could say 10 at 2, and the whole thing should get smaller, right? And then I can zoom a little, and I think that should work. So that's how you change your grid. You can also move the grid origin. You can do some pretty advanced things up here. So, okay. So if I go back to home and I click on member, you'll see in my properties box here, all of the options and general properties of the member pop up here, right? And so it says, do you want to, and this is confusing a little bit because you can actually define a member in multiple different ways. You can define it directly using the material and the shape. Or, as I was showing you before, you can, where it says shape database here, if you click on the little down button here and you change that to section set, what you see is that a whole bunch of this stuff gets grayed out because all that stuff is predefined by the section set, right? And that's my preference because that, like I said, we have those advantages of being able to change them later. All right, so if I go up here, now the section set is by material. So so if I click on the section set here, it only shows me the one. HR stands for hot rolled 1, because what I have those. That's the only one that's defined for steel. So if I go up here to material and I go back down to general, now I get the ones that I defined, right? So the 6x6, the 4x4, and the 6x12. So what I'm going to do is I'm actually going to draw them all as 6x6s, and then. Actually, while we're here, you'll notice here that there's an I release and a J release, right? And so I can make those hinge. This is how I would put in hinges, right? I can either type there or I can click on this and it says, do you want it to be pinned at the I end and pinned at the J end? You can fix, typically if you're pinning something, you want torsion to be fixed. Then there's a whole bunch of more customized complexity here that we don't need to get into right now, but that's how you would. So if I, for example, click on pinned, then you see it says like bend pin right here. So for this structure, I want everything to be fixed, which is actually kind of funny because you generally can't create rigid connections in wood, but we're going to do it anyway. Such is the power of computers. And so now I'm just going to draw, and so this thing is 10 feet tall, so that should be oh, these are by 2, so 10 feet is going to be down here. You'll notice if I hover over a joint, it gives me the coordinates. And then 12, and then down 8, so that's going to give me something like that, right? Now if I hit escape, that goes away, and everybody's happy. Okay, now if I go back to home here, I've got all this quick view stuff up here in the top right. So one of the things I can do is I can click on the little I-beam, which says render. And if I click it once, it gives me this coloring, and it says that the section set is a 6x6. If I click it again, it actually will render it. And if I rotate it around a little bit, you can kind of see, you can see that those are 6x6s, right? Okay, but I don't want them all to be 6x6s, right? Because the top is a 6x12 and the right is a 4x4. So there's a couple of ways to fix that. The first one is to get out of this drawing mode, and I don't know how to do that. Oh, I guess if I click member again, then it goes away. Now if I get my little arrow there back, and if I hover over this and I click on it, come on. Now what you see is all of the properties of just that member on the right. It tells me what the member number is. It tells me how long it is. It's 12 feet long. And it tells me that I have chosen a 6x6. And so I can change that to a 6x12. And now it's changed. And if I click back in here and I hit escape, you'll see that now it's green, right? Because now I've got a blue 6x6 and a green 6x12 as indicated by the key in the top right. So I can do that again for the one on the right and turn that into a 4x4. And if I hit escape, again, now I have 3 colors, right? And 3 labels. So now that's what I want, right? That's what my model looks like. So I'm done selecting my members. Just for fun, if I click on this, there's also 2 other things down here. One of them is additional properties. And that's actually how I define my nodes, right? So if I change that to node 1, you see that it changes the locations of the nodes. And then more useful than that, potentially, is this thing called rotate. And so if I hit escape here and I go back to home and I go clicking through renderings again, right? And so if I wanted to rotate this member, what I would do is click on it until it shows up. Come on, there we go, in the left here, member M2. And if I rotate that 90 degrees and hit enter, you'll see that it rotates 90 degrees, right? So that's how you would rotate. And you know, just for funsies, I could rotate it 45 degrees and then that would hurt my brain. So I'm gonna go back to 0. There are also some other stuff here which you don't need to worry about for now. And then there's also some design properties, which again, you don't need to worry about for now. So, okay, so I'm gonna go back to here, oops, and I'm gonna go back to here. And so now my next step is to define my boundary conditions, right? And so if I'm on the home ribbon here, there's a thing here called boundary conditions. So if I click on that, again, under my properties, I get some options here, right? I can do free, fixed, and pinned. This is the same as the 2D version. And so I want this to be fixed on the left. And so when I click fix, I see that. And then you can either apply to everything, which you rarely want to do for a boundary condition, or click to apply. So I'm going to click to apply, and then I'm going to either click on these or box them. And so that works for that one. I'm going to go back up here, click pinned, click to apply again, and then box the right one, and now I'm done, right? And if I want to check these, I can hit escape here. Again, I have all my spreadsheets over here on the right, right? So if I click on members, and it's in alphabetical order, I think. No, it's not. It's in some totally arbitrary order. I don't know. You know, I don't know where they came up with this order. But if I click on members, I get a spreadsheet. It shows me my member, where the nodes are, whether or not it's rotated, what's the section set, and then, you know, since the section set defines this other stuff, these are grayed out. And then there's an advanced tab here where you can get even more stuff, right? So that's the member one. The node locations, node coordinates is in there, right? If I wanted to move a node around, this is where I do it. And then also the other, boundary conditions. So boundary conditions is here, right? And so you can see that I have reactions. There's other boundary conditions. One of them is fixed. Fixed is the same as reaction, you just won't get a reaction. So that's kind of weird, but it won't tell you the reaction. They'll have the same behavior. Okay, so I define that. My next step is to apply my load, right? You'll notice that it's 600 pounds per foot. If I change my units to pounds per foot, it'll fix some things. And then if I go here to home and I go over to draw loads, there's a line load. I'm going to click on that. And so now I have to stop and talk a little bit about load, why this says this says BLC right here, basic load combination. So depending on when you're watching this, you may or may not have discussed this already in class. But if you have, then you will recall that there is, and so I'll do the quick version here, which is that there are different load cases. and then there are different load, and then you combine them differently, right? So the idea is if you have a beam, right, you may have dead load on it, you may have live load sometimes, and then, you know, other times you might have, oops, I was supposed to change color, you might have snow load. And sometimes you might have a little snow and lots of people, and other times you might have lots of people, or lots of snow and no people. And so the idea behind the load combinations is to combine those, but it's not always just a straight sum, right? And so the these are the load combinations that are defined by the document that governs this, which is ASCE 7. And what you notice, of course, is that, you know, there's one that's dead plus live, right? And then there's another one here that's dead plus 75% of live plus 75% of snow. And then there's an additional factor here, which has to do with how snow is defined, of 70%. So, and you have to check all of these. And so the way that Risa has grappled with this problem is basically you define each of these as a basic load case. And then you define each of these as a load combination. And one of the things that you can also do is you can have multiple basic load. You can have as many basic load cases as you want under a particular category, right? So, for example, you might have a live load, basic load. You might have a basic load case for live load on the floors, and you might have a different basic load case for live load on the roof. And so you can mix and match and do whatever you want. There are also additional ways of categorizing these, as we'll see, such as categorizing. So if I go over here on the right and I click on basic load cases, what you'll see is that it has a description, and then there's 3 columns for gravity, and then there's a bunch of columns. The 3 that you're interested in is the first 3, which is the different types of loads. You have nodal loads, point loads, and distributed loads. And I think in Risa3D it's the same in that nodal loads are loads applied to joints, and then point loads are loads applied to members somewhere in that member, right? And one of the deceiving parts about this particular spreadsheet is that this is actually a spreadsheet of spreadsheets, right? So if I click on nodal here, I get another spreadsheet, right? And what happens if I put some stuff in here and I close it, you'll notice is that there's a 3 here, right? Meaning there are 3 nodal loads. It doesn't tell you what they are, right? In order to find out what they are, you need to click on that. So I'm going to get rid of those by pressing F4. All right, so for the problem that I have given you, which I need to find again for me, right? I have not defined these loads, but let's say that the vertical load is a snow load, and the 600 pounds per foot is a snow load, and the side loads are wind loads, right? So I'm going to say dead load, and then I'm going to say snow load, and then I'm just going to say snow, and then I'm going to say wind. Right, and so then there's this thing here called categories, so you can actually put these into categories, right? Dead load. So you could do, and that has to, things get a little complicated. You can, like I said, you can define multiple basic load cases, define them all as dead load, and then, you know, for example, in your view of your model, you can just show all dead loads, right? And so generally, I don't use this because it just confuses the issue because I'm already kind of doing it, right? And so you can use it. And then Risa has some tools that'll auto-generate load combinations if you categorize everything, and those are more advanced tools. All right, so the gravity here is telling you, okay, I know how big the pieces are. I know how dense the pieces are. And so Risa can actually calculate the weight of each piece, right? And then apply that as a self-weight. And so, what it needs to know is how much gravity there is and in which direction it is, right? And so, in my case, gravity is down in this view, and so that's y. And so I'm going to put in a negative y. You need to be, a -1, right? Meaning 1 Earth gravity, right? So if you're on the moon, that would be 1/6. If you're on Jupiter, that'd be -2.5. And if you accidentally put in a 1 instead of a -1, you'll see your structure go up, right? When you apply gravity. So, all right. So that's my dead load in this case. My snow load, and so there's 2 ways to apply loads, right? Because I can go in here under distributed load. I can click on that under snow distributed. I get this dialog box, which is a spreadsheet, and I can click somewhere in here and it will create a load, and it'll ask me what member, what direction, start and end magnitude, start and end location, right? Or maybe more useful is once I've defined my basic load cases, I can go up here in the ribbon and I can say, well, I want a line load, right? And so then it gives me this properties up here in the top left, and I can say, well, this is a snow load. It's in the y direction, and it's going to be at -600, and it's a full length, right? You can also do partial length, and then you click to apply, and then I'm going to click on member 2, and there it is, right? Now you need to be a little careful about what you're looking at. So up here on the top right, it says this is what you're looking at. So right now I'm looking at basic load case 2, right? I can change this to load combination or load category, and I can change this to the various different basic load cases, right? So if I click on wind, there's nothing, right? I haven't defined anything in the wind load case yet. All right, so I'm still stuck on this line load thing, so I'm going to hit escape. And then I'm going to go up here to nodal load. And this is going to be a wind load, and it's going to be in the X direction. And it's going to be negative, at joint C is -3.1 kips. And you'll notice right here it says magnitude, and it tells me the units in kips, -3.1. Click to apply. I'm going to apply it to that joint, and now it says 3.1, right? And then lastly, I'm going to go back to home. I'm going to click on point load, because the last load is actually in the middle of the member. And so, and you'll notice here that I can choose big X, big Y, big Z, little x, little y, little z, right? Because I can either apply it in the global axes or the local axes, which in this case are different, right? Because the member is vertical, which means that its x-axis is going to be vertical. And so I like to keep things in global, so I'm going to do big Y, big X, wind load, and then -0.8 because it's 800 pounds. Click to apply, and then I'm going to click on that green member. Oops. And the problem is that it's stuck at 0%, right? Which is not where I want it. So I'm going to do Control Z, and then I have to start over. So I go to point load, all my stuff saved, so it's still there, but now I want it at, so you can do it in feet or you can do it in percent. And I think if you do it in percent, you have to type the percent first. The advantage to percent is that if you make the member longer, then the load will stay in the middle, right? If you make the member longer and you defined it as 4 feet, it doesn't stay in the middle, right? It stays at 4 feet. So, okay, so now I have applied my loads, I've applied my boundary conditions. Maybe I think that I'm ready to solve. And so if I click on solve, it's going to give me this error and say no load combinations are defined. Because, right, if I go back to my description here of this, right, I've defined my basic load cases, but I have not defined my load combinations, right? So it doesn't know what to do with that. And so what I'm going to do is, if I click on down here at the bottom of the Explorer on the right, there's a spreadsheet that's the load combinations. I'm going to click on that. And then it gives me a blank one. I'm going to click on that. And now I have a single line at the top. And I'm going to define it. I'm going to say dead, right? Because load combination 1 is just dead load. And then I'm going to go over here to BLC. And if I click on the dots, it's going to ask me which one, right? And I can just click 1 and put in that one and say OK. And then the factor in this case is 1.0. I can also just type it, right? So if I hit enter, I want dead plus live, and so that's 1 BLC. I don't have a live load, so let's skip that and go back to dead plus snow. In this case, it's dead plus 0.7 snow, and so 1 load factor 1 again. Now I'm going to have, I believe my snow load was 2. And my factor is 0.7. It's a little annoying that the factor is after the BLC indicator. And actually, you'll notice here that I screwed this up. It says dead load. That's not what I want, because my radio button's up here. I want my radio button down here under basic load case. Again, this is the category mode, if you will, where you could just apply all the dead loads, right? So you could use multiple basic load cases to define dead loads, but as long as you categorize them all as dead load, then you can just apply them all in one swath. This becomes useful if you have like dead load that's concrete and dead load that's wood and dead load that's furniture or partitions, and you want to define them all separately, and then you just want to apply them all at once. Okay, so that's 2 of them. I'm going to do 2 more. I'm going to do dead plus, actually, sure, I'll do dead plus 0.6 wind. And so now this has to change. Oops, this is wrong. This is the basic load combination 2. There we go. And this one's going to be 3. And this is going to be 0.6. And then the last one is dead plus, it's 0.75 times 0.6, which I believe is 0.45. Yes, 0.45 wind plus, and then it's 0.75 times 0.7, which is 0.53 snow. And I can make this bigger so I can see them. And so now I have 2, 0.5, it's actually 0.525, and then 3, and this one is 0.45. Right, so I have 3 basic load cases being applied. Okay, so that's all done. Now one of the things I can do is look at it, right? So if I change what I'm looking at from BL's basic load cases to load combinations, I can see that in load combination 1, I can't see anything. There is actually load applied here. It's dead load. We're self-weight, but I can't see that. 2, I have my 0.7 times my snow load, right? So the 0.7s aren't already applied to that 600-pound snow load. 3 is my wind load with factor applied, 0.6. And then 4 is all 3 of them with factors applied. Okay, so now I am ready to solve. So I'm going to solve this. I'm going to click this blue equals button up here and click solve. And now it's telling me that I have options. I can do single load combinations. I can do envelope, which is basically the worst case of all my load combinations. And then I can do batch, which is do them all and keep all the results. The envelope basically does them all and just keeps the worst case. And so I'll show you what happened in each of these. And the place where it says marked, if I cancel this and go back to my load combination spreadsheet, is this guy right here, right? This checkbox. So in theory, you can have 20 load combinations defined, but you only want to solve 4 of them, so you can uncheck some of these boxes. Okay, so I'm going to solve the first one. And it gives me some stuff. It gives me an error. The members are defined as beams, but they're vertical. This is just a check that they have. I could go back in here under members, and I could define define them as, I don't remember where. I guess you define them under section set. That's weird. No. Maybe it's under the member itself. Okay, well, somewhere you can define them as columns, but we're going to ignore that because nothing that this thing is doing cares, right? It mostly gets into some of the code provisions for the difference between a beam and a column, like in steel design and wood design. So we don't really care. So we're going to ignore that warning. You'll notice that on the bottom right here, if I hover my mouse over here and scroll down, I have results and I have a whole bunch of new spreadsheets, kind of like the education version. So you have node reactions and node deflections and member forces and member stresses and all kinds of cool stuff. I'm actually going to get rid of my grid, which again is under drawing tools. And so there's a couple of things I can do. Now, first of all, you got to be careful what you're looking at, because right now I have a solution for load combination 1, but I'm actually looking at the loads for load combination 3. And so a couple of things I want to show you. The first one is this second guy right here where it says display results. So if I click on that, it actually gives me nothing because it's not solving for design events. But more importantly is this little one right here that says deflections. So if I click on deflections, you'll see it just slightly is bending under its own weight. So let's do something more exciting. If I solve for load combination number 2, which is dead plus snow, it gives me a warning that says you're going to clear your results. And this is kind of important if you have a huge model, because it might take 20 minutes to solve your model. And so then you want to be alerted to the fact that you're clearing your results, and you'll have to run that for 20 more minutes. But in this class, you're only going to be using, most of your models will solve very quickly, and so you don't really care. Okay, so it solves again. It gives me that same warning about columns and beams. It automatically brings up reaction force spreadsheet. I don't know why that's the default, but and so now you see deflections, right? There's a deflected shape here as a result of clicking on this button. Now, again, you need to be careful. It's showing me the deflected shape of load combination 2, and down here in the bottom right, it's telling you that. It says what you're seeing, loads, is load combination 2, and the results is for load combination 2. In theory, I could change. Oh, it won't let me. Well, that's nice. Maybe if it used to be that you could show the loads for load combination 3, but the results of load combination 2, which hurts your head and can really mess you up. So, okay. If I do that, nope, it goes back. Okay. Okay. So other things you can look at. Most of them are up here under quick view, right? So if I click on this little guy, you can see the different diagrams. So here are the axial diagram. And if I do the little caret to the right, you can come up with the shear diagram, which we care about the Y shear, so it looks like that. That's good. You can do the MZ. That looks good. And then one other button that I forgot to talk about actually is this guy right up here in the top right of the model view, of the 3D view, which is basically, if I hold it over, it says 2D mode, which I didn't actually have a problem with the fact that this is a 2D model being solved in 3D space, but the reason for that is because this is a fixed condition, and so it's preventing the model from leaning over. So for example, if I change this, and again, if you change anything on the model, then your results get cleared, which makes sense, right? Because you're changing things. So if I change this to a pin, and then I try to solve it, it gives me a warning that it's unstable, right? It says instabilities were detected, and so it's going to automatically lock something. Risa has some algorithms that basically try to fix your mistakes, and so it'll try to lock some things. Now, it might do it wrong. It might lock something that's actually not locked in real life. or locked is another word for like made rigid. And then it's asking you, would you like to open the locked node view so you can see what's being locked, basically. And it gives you this special view that says like, oh, we locked node 2, right? And so so in order to prevent that, one of the things you can do if you're solving a 2D model in 3D space is you click on this little 2D lock button. And so this brings the whole model, it's going to clear your results because those are invalid now, the whole model basically into 2D. Right, so this is the button that changes Risa3D back to Risa 2D, right? And so now if I were to solve it, it's not going to give me an instability notice. It's still going to give me that columns beams notice, but now it's not unstable, right? So that's going to be your that lock button is going to be your friend because you're going to be doing a lot of models in 2D. Okay, so now I'm going to go back and make that guy rigid again. Or fixed is a better term. And solve it. Now I'm going to solve for the envelope, right? Well, it's just for fun. Let's solve the fourth combination, right? And so if I show my deflected shape, it looks like that. If I show my moment diagram, it looks like that. Right. I can also do things like I can color code stuff. Right now it's color coding by section set. I can color code by well, most of these I would have to explain, but here's a member type, right? And so you'll see that they're all well, two of them are beams and one of them's a beam and the other two are unassigned, right? So so there's ways of like showing, you know, what it is you're looking for. There's also this one, which is the label. So you can label, you know, the label number, the member label number. You can also label the nodes. You can label the shape that it is, right? This is a 11.5 by 5.5 inch rectangle. The section set that you're using. So if you want to know information about your model, this is kind of the place to go, right? You can also do your reactions right here, right? Maybe I want Y, X, and moment about Z, right? So now I can see these reactions. There's also this thing, which I'll show you now. So if I show the deflected shape again, if you go under View and you click on Results, there's a bunch of options here. One of them is how much you're scaling your deflected shape, right? So I can bring that down and apply it, and now it's just scaling less, right? Now the deflections are the same, but it's just a view of my model, right? If I want to know what those deflections are, I can go over here to Node Deflections, and it tells me, okay, it's going 2 inches to the left. This one's slightly more, right? And then my Y deflections are tiny, tiny. And then the other thing, so now if I go back here and I solve under envelope, do I want to clear the results? Yes. It actually takes a second longer because it's solving all three of them and taking the max. And so now if you look here at my reactions, right, at N1 I have a max and a min, and it tells me which load combination that is, right? And so for the max Y, it's load combination 4. For the min, that's load combination 1. That makes sense. That's the self-weight. And if I then go to try to show those, for example, it shows it as 2.7/0.2, right? So max and min. And if I were to show the moment diagram, you'll see a moment diagram that can't exist in real life, right? It's like both a triangle and a parabola, and that's because that's the envelope, right? The worst possible case in the positive is this green one up here, and the negative is the blue one. And then the last thing I want to kind of show you is this button right here, which is a little square, and it's got some like pretend text on it. And if you click on that, and then you click on a member, you get what's called a detail view, or detail report. and it tells you everything you'd ever want to know about this member, right? It tells you the size, the length, what it's made out of, how many internal sections it's calculating, because again, this is a digital computer, right? So it can't actually come up with these curves analytically. It has to basically calculate the curve at however many locations and then plot it. And so there's some finiteness to these curves. And then it's got a bunch of diagrams here. It's got axial force, it's got moment and shear in both the Z and Y directions. It's got deflection in both the Y and Z directions, and it's got stresses in both the axial, bending, and strong and weak axes, right? Because it knows how big your member is, so it can calculate the stresses for you, right? Just MC over I. MC over I. And the other thing that's cool about this is that each one of these is actually its own graph. So if I click on that, then I get a much more detailed version of it. And if I roll this location thing around, it'll tell me the value at that location. You can see it's jumping from section to section, right? That's because of the number of sections you told it to calculate. And so if I wanted to, for example, know the deflection at 3 feet, there it is, right? The max value is 0.111, tells me the load combination, or the negative is 0.138, tells me the load combination, right? And it gives me the blue and the red, which is the max, which of course in this case, in the uppercase, does not occur at the middle. So lots of cool stuff. You can do the same thing with the moment diagram, right? If you want to know the moment at a particular location. And so there's a ton of detail here that you can query. Okay, and then last we solve the batch solution. You can include the envelope or not. And so, yes, I'm going to write over my results. Yes, I know some of my beams are columns. And then the nice thing about this, if I click, for example, on member forces, and so if I look at member 1 here, it actually gives me it's a little annoying how it does this. Well, this is kind of the same thing as before. It's giving me the if I do node reactions, it's giving me the max and the min and telling me which load combination it is. If I believe if I solve this and don't include the envelope, so here it's giving you the result for every, these are reactions, right? And so it's giving you the result for every load combination, right? So here's load combination 1, reaction at N1, reaction at N4, total reaction, and then load combination 2, load combination 3, load combination 4, right? So I can go through the list and be like, oh yeah, my total should be, you can sum up your verticals and see if it matches the reactions. So, and then when you go to do things graphically, you get the same sort of thing, right? So this says 0.2 and 0.1. That's because it's I'm highlighting load combination 1 here. So if I change this to load combination 4, then I get different reactions. And so basically I have every solution of every load combination built in there, and I just need to pick what I want, right? And so sometimes you want the envelope because you just want to know what the worst case moment is on your beam, and sometimes you want to know what is exactly, what does the moment diagram or the loads or the reactions or the deflections look like for a particular load combination, right? Okay, so that pretty much concludes my discussion about Risa3D. I know that's pretty long and there's a lot going on there, but hopefully that will help you to start using this software.